All right. Hey, Lorenzo. How are y'all today? Okay. Let's see. Yeah. Today's Friday, last day of class. Um, Again, we're going to review today. Um, so, as a reminder, um, and I've been emailing the facilitators, so hopefully everything is working out that um, we're all scheduled to take the final exam next Wednesday from 8 to 10. Um, that needs to be a 2 hour setting, not broken up. Um, so hopefully everything's getting worked out there. If there's any conflicts that are arising, or if you are going to be tested in a different room, that's fine with me. Um, I was, and again, facilitator. If you're, is a Lorenzo, is y'all's facilitator in the room? Okay. So, to the facilitator, I sent an email about this yesterday, and I guess my concern was um, this particular class, if you're testing from 8 to 10, um, the at this current state, the ITV connection, because this class starts at 10, um, y'all wouldn't be ever connect. I guess the time that y'all connect to the ITV stream is going to be at the end of the final exam, and I was concerned about that, but it doesn't sound like y'all are concerned about that. So if y'all are good with the current status, I'm not going to ask for the ITV system to be changed where um, it's now set up so that everybody's connecting from the 8 to 10 slot. Um, if that needs to be changed, let me know. Please reply to my email that I sent out yesterday about this. I just want to make sure that if a question comes up or an issue comes up, that the easiest thing to do for convenience sake is that we're connected by an ITV system, but um, I'm also going to be available by email. So let me know if you haven't done so already. Let me know what your thoughts are, or just feel free to chime in right now what your thoughts are in regards to the current situation with the ITV system, being the fact that this class won't connect until after that 10 o'clock session. Any thoughts?
So we'll start the exam at 8.
Yeah, so, and look, here's the other thing. If it's easier for y'all to start the exam at 9 and go to 11, that's fine with me too. Um, it's a 2 hour exam. So, um, this is something that y'all have to coordinate with your other instructors, their other classes. And I guess I really should have been saying this early on. I've never ever had a problem with scheduling the final exam. So if you need to schedule it so it's from 9 to 11 on Wednesday, that's fine with me too.
Because we have class for English that starts at 9 to 10. Well, 9 to your class.
Now, here's my question. Have you told your English teacher that you have a final exam?
Yes, sir, but she has a final exam too, but I don't think it's on the same day. And I don't know if she wants us in the same class.
Yeah, see, that's so I number one, I probably should have been stressing this more, but yeah, you got to be talking to your final exam teacher. You got to, and so you got to coordinate things. Now, all I care about is that the final exam gets done. So, like I said, and facilitator, I hope you're listening. If y'all need to schedule something that's different than the 8 to 10 o'clock slot, that's fine, but let me know.
Okay. Good morning. What I will do is that I'm going to email Miss Thompson because their final exam for English is on Monday, the 13th. So what I will ask her if she is going to have them on Wednesday uh, at 9. If not, I will let you know because I have no problem at all whatsoever to work with them from 8 to 10, from 9 to 11, because I'm with them all during the 3 periods either way, so it's okay. But I will
Okay,
let you know. I'll email Miss Thompson and I will let you know right away.
okay. Um, and so back to my other question. Um, do you, um, I guess, yeah, just let me know what time you are going to be taking the exam. Um, if it's from the 8 to 10, I may just go back and talk to our ITV person and see if she can um, um, adjust the setting so that our ITV connection starts at 8 and goes to 10. But I don't know if that's necessary. I don't know if that's a necessary request. If y'all want that, I can request it. But if y'all are okay with not having that situation, I'm fine with that too. Does that make sense?
Yes,
Facilitator, does that make sense?
yes. I will work things out with Miss Thompson, and once I have her reply, I will email you. And it depends on you really. Do you have to be on the ITV while they're taking the test, or as long as I am here with them?
As
Um, to
Yeah, so I have another class that they're going to take their test in a different room other than ITV room. And I'm fine with that just as long as the facilitator is maintaining the integrity of the test. All you're doing as a facilitator is just making sure that the students are doing their work, no cell phones, that sort of thing, and they're doing their own work. And I'm just relying on you, the facilitator, to be maintaining the integrity of the test. And so if y'all take it in a different classroom or a different time, or if we're not connected via ITV, I'm fine with that, just as long as, and I'm going to know that you're going to do the right thing as a facilitator to maintain the integrity of the test. So I leave that decision up to you.
Okay, that works. Because I'm with them through from 8 a.m. all the way to 11, either way, almost every day. So it
Okay.
should work fine in any event.
Great. Sounds great. Who am I speaking to? Is this Miss Gina Chen, or am I wrong? What's your name?
Miss Gina.
Miss Gina? Okay. I got it right. Um, what was I going to say? So I guess really the 2 points, just I've already said the first one, just making sure that the integrity of the test is maintained, and number two, I would love to have that test um, at the earliest convenience, so that I can get to grading them. If that makes sense. So, anyways, thank you very much, and
My pleasure. Thank you.
I'll look forward to your email later on. All right. What can I do for y'all? Are there questions on the final or an exam or quiz or a homework problem that we need to look at?
On the final exam, can we go over question 50?
Sure. Problem 50. So you mean the review, final exam review? Sure.
Yes, sir.
Alright, problem number 50. We have the rational function f of x is equal to an x plus 2 over x squared plus 3x minus 4. Alright, and all it says is, find horizontal, vertical, asymptotes, additional points as needed, sketch the graph. So, in no particular order, the first thing I'm going to do is I'm going to find that vertical asymptote. So, for notational purposes, I'm going to call the top P of x, the bottom Q of x. Here we go. How do we find those vertical asymptotes? We need to solve Q of x equal to 0. We need to set our denominator equal to 0 and solve. So x squared plus 3x minus 4 set equal to 0. I would consider factoring this. So what are the factors of negative 4 that add up to 3? How about a positive 4 and a negative 1? Which we know at this point you set each factor equal to 0 and you get x is equal to negative 4 and x is equal to 1. So here are our vertical asymptotes. B, finding that horizontal asymptote. Alright, so two ways to do this. If you compare the degrees of P of x and Q of x, we have 1 versus 2. The degree of the numerator is 1, the degree of the denominator is 2. We can then declare that 1 is less than 2, and the conclusion is that y equal to 0 is our horizontal asymptote. Now, there's a reasoning behind this, so I want to take just a quick moment here to talk about the reasoning. Why is this so? Pick, not pig, pick a big x. So let's do x is equal to 1,000. I mean, 1,000 is actually kind of small, but it's big enough for our purposes. Pick a big x. Now, f at 1,000, if you plug in 1,000, in the numerator it's pretty easy. You have 1,002. And in the denominator you're going to have 1,000,000, 3,000 minus 4, so that's going to be 2,996. Now, if you plug that into your calculator, I don't remember exactly what you get, but you get something like a 0.00 step after that. And what ends up happening, if you go bigger, if you do like f at 10,000, I'm not going to do this, but what ends up happening is you get 0.00, maybe another 0, ... As your x's get bigger and bigger and bigger, your answer is getting, you're adding more zeros in your decimal approximation, which means it's getting closer to 0. As your x's get bigger, that means your output value is getting closer and closer to 0. So the idea is this: as x starts approaching infinity, f of x is going to 0. What is f of x? F of x is the same thing as y. Y is going to 0. That is why our horizontal asymptote is at 0. This graph is getting closer and closer to 0 as your x's go out towards the infinities. Now, additional points might include your x-intercepts, if there are any. How do you find the x-intercepts? You solve p of x equal to 0. So what is p of x? It's x plus 2. So that means x is equal to negative 2, or we have the point negative 2, 0. There is our x-intercept. That is where the graph crosses the x-axis or touches the x-axis. It's the only x-intercept, by the way. Nowhere else is this graph going to touch or cross the x-axis. Additional point might be the y-intercept. How do you find the y-intercept? You evaluate f at 0. So if I plug in 0 into my function, I end up with a 2 over a negative 4, which is a negative 1/2. So that makes my y-intercept at 0, negative 1/2. So there's my asymptotes, my intercepts. Let's get a sketch of this graph. Alright, so first of all, at negative 4 and 1, I have vertical asymptotes. At 0, I have a horizontal asymptote. Alright, what else do we have? We have an x-intercept at negative 2, a y-intercept at negative 1/2, so I'll plot those points. Alright, now, I'm going to use a little bit of logic here. Number one, this is our only x-intercept. Nowhere else does the graph cross or touch the x-axis. So if I just connect these two dots, I gotta think about what does the graph have to do after this point. Well, it can't go up because if it went up, it would cross the x-axis, meaning there would be another x-intercept. Well, again, this is the only x-intercept. So what does the graph have to do? It has to go down. Now, going back to we've talked about multiplicities, repeated zeros. Well, this 0 at negative 2 comes from the expression x plus 2. And that expression x plus 2 only occurs once in our function, meaning it has a multiplicity of 1, which is odd. Odd multiplicities mean that it crosses the x-axis. So if it goes through the x-axis, it can't go back down, because if it went down, it would cross the x-axis. Well, there are no other x-intercepts, so what does it have to do? It has to go up. Now, I did that all just using a little bit of logic. Could you have plugged in points, like at 0.5 and at negative 3, to find out what the graph is doing? Sure. Alright, so there's my logic. Now I have to decide what the graph is doing over here and over here. So I'm going to go through and I'm going to pick some test points. Let's do x at negative 10. And all I really care about is if it's positive or negative. Now, when I plug negative 10 into this function back up here, I get a negative 8, which is negative. And then negative 10 squares 100 minus 30 is 70, minus 4 is a 66. That's positive, and negative divided by positive is negative. And if I do f at positive 10, I'm going to get a positive 12 over a, that's going to be a 126, which is positive. Positive divided by positive is positive. And this tells me what the graph is doing to the left and right of my vertical asymptotes. Over here to the left of negative 4, it's negative, so what does the graph have to do? It has to do this. It has to be below the x-axis. Over here at f at positive 10, the graph is positive, so what does the graph look like? It has to look like this. And there's a sketch of our graph. Does that make sense? Great. All right, what else can we look at?
Mr. Clopton, before you continue, Miss Thompson just emailed me back, and they don't have to be present in her class on Wednesday. So we should be fine starting at 8 or starting at 9. It will depend on the students.
Okay. So, I'm going to let y'all...
And if we don't have to be in the ITV room, then they can be in my classroom because it's a lot more comfortable over there, and I can have them more separated and them working in a better way, if it's okay with you.
Okay, that's fine with me. So, I would just ask that you just send me an email just stating what's happening, telling me that you are going to be in a different classroom. What is happening?
Okay. No, hold on. I just changed the camera. There you go.
Okay. Yeah, just let me know what's happening as far as your RGB test in a different room from 8 to 10. That way I just have notes about what's happening with this particular class.
Sure thing. I'll email you right away, and I will email Mr. Calvillo, which is the other facilitator for the students. So everyone is on the same page.
Great. Thank you so much.
Okay. You're most welcome.
All right. So to the students, I guess this will be the last time I see y'all. So I'll just say it right now. Thanks for being my students. I've enjoyed the semester, and I look forward to, I think you said that you are taking trig in the spring. All right, I look forward to seeing y'all then. All right, cool. So if we don't get a chance to say goodbye this semester, there's my goodbye. Let's talk about what other questions you have on your plate.
70.
Say that one more time.
70.
70.
70. Mm-hmm.
70. So, while I'm thinking about it, I don't know if I've mentioned this. If you recall, if you go back and look at your second exam had a formula sheet, a little table of formulas. You will have, it won't be the same formula sheet because I've added some formulas to it, but it's going to be kind of the same situation. There's a series of problems that, like in exam 2, I just gave you the formulas for. This is going to be one of the problems where I give you the formula in the formula sheet. 70 and 69 both require formulas. Those formulas will be in the formula sheet, but you have to know when to use which formula. That's part of, I'm giving you a bone here, so to speak, but you got to know what formula to use in a given situation. So I'm about to write the formula down for this problem. It will be on that formula sheet along with a mixed bag of other things that we've come across. All the formulas for exam two will be on there. And I can't remember what ones I've added, but things that require formulas. So here we go. Um, One formula that's not going to be, stuff like Kramer's rule. I'm not going to give you Kramer's rule. I expect you to know what Kramer's rule is. Things like the relationship between logarithms and exponents. That's not really a formula, that's just something that you got to know. All right. So let's go back to your question. Problem number 70. Now, after I read the problem, I see this phrase called compounded continuously. Continuously. So, compounded continuously means that we are going to use the formula A is equal to P times E raised to the RT. Compounded continuously, here is our formula that we are going to use. So, reading through this, it says find the accumulated value, so we want to find A. So, if we're going to find A, we need to know what P, R, and T are. E is just the natural number. It's a calculator operation. P is
Mr.
going to be
Compton,
the... Yes?
your screen's really pixelated. We can't see what you're writing.
Oh, the TV?
Yes, sir.
Yeah, I'm looking at y'all's, I can see y'all's screen behind y'all, the screen behind you, and I can see my hand, pixelated. Alright, all I can say is this, I can hear the wind outside, and I bet that wind outside is probably causing some connection issues. And that's just out of my control. I can't do anything about it. So my advice is listen to what I'm saying as much as you can, follow along with it as much as you can. The session is getting recorded, so if you miss something, go back and look at the recording. The recording should be spot on. There shouldn't be any problems with the recording. So I can't do anything about the problems with the pixelation. Okay? Alright, sorry about that. Alright, so R. They give us that the rate is 5.25%, so we got to convert that to a decimal number, so that's going to be 0.0525. And then T is 7 years. So we're just going to plug this information into this formula up here. A is going to be equal to P, so that's going to be 3,000 times E. In my calculator, it opens up with the little house top and then opens parentheses. And we have the 0.0525 times 7. And if you type that in exactly as it's stated, you should get that approximately 4,332.36. With your calculator. Do you get that with your calculator? Okay. So you'll be given this formula. It will be on the formula sheet. You'll also be given, so for problem number 69, the key phrase is compounded, what does it say, compounded monthly? And when it says compounded monthly, the formula that you use is A is equal to P times 1 plus R over N raised to the NT. Again, that formula will be on the formula sheet. Yeah, my hand is, that's really freezing up. Everything is really freezing up. I don't even know if y'all can see me. Y'all are still. Can y'all hear me? We got disconnected. Hey, all right. All right, hey, we're back. We're back. Cool. I was listening to that wind outside, and who knows? All right. So we were just talking about um, problem 79 and 69, the fact that those require formulas, and if those um, occur, problems like this occur, you will have these formulas on the formula sheet. All right, what else can we talk about?
13.
13. We want to solve negative 3, absolute value of 4x plus, should be minus 7, closed absolute value plus 15 is equal to 0. Alright, so with solving an absolute value equation, we want to isolate the absolute value of u. Now, a couple of things to remember. Do not distribute into absolute value bars. You cannot distribute that negative 3. Don't do it. Don't distribute that negative 3. Instead, say, I gotta get this by itself. So what do we do first? We'll subtract the 15. The next thing that we want to do is we want to divide by the negative 3. So everything gets divided by negative 3. So we get absolute value of 4x minus 7 is equal to now negative 15 divided by negative 3 is a positive 5. Now, how do we solve this? Well, here's the idea. If the absolute value of u is equal to d, then u is equal to plus or minus d. There's going to be two values of x that are going to satisfy this equation. So we now say that 4x minus 7 is equal to plus or minus 5. So I'm just going to keep solving this. 4x is equal to 7 plus or minus 5. Then x is equal to 7 plus or minus 5 all over 4. Alright, so let's solve this. First of all, you get x is equal to 12 over 4, which means x is equal to 3. And second of all, 7 minus 5 is going to be 2 over 4, which is going to be a half. So our solutions are 3, comma 1 half. I should just write this as x is equal to 3, x is equal to 1 half. Does that make sense? Alright, cool. What else can we look at?
$23.
23. Two times the absolute value of negative 25 plus 3 times the absolute value, square root of negative 25, square root of negative 49. So this is going to force us to recall some thoughts about complex numbers. First of all, we have that I is equal to the square root of -1, which then would imply that I squared is equal to -1. But for this problem, we're going to be taking a look at this. This allows us to go about the process of evaluating the absolute value of a negative number. So what we're going to do is we can think of this as the absolute value of -1 times b, split your radical, and since the absolute value of -1 is I, this gives you I times the square root of b. This is how we evaluate the square root of negative numbers. So when I look at this expression up here, what I can do is I'm essentially just going to take that negative out of the radical and bring it out in front as an I. And then you're just left with the square root of 25. Same thing here. Take the negative out of the radical, bring it out as an I. And now I'm going to ask myself, can I evaluate these square roots? Well, sure. Square root of 25 is 5. Square root of 49 is 7. And now I can take 2i, multiply it by 5 to get 10i. 3i times 7 is going to be 21i. And since these are both like terms, I can add them together to give me 31i. Now, another way to do this is we just, at some point, we just start recognizing, oh, square root of -25, that's 5i. Square root of -49, that's 7i. And then this is going to take you right back up here to 10i plus the 21i, which gives you the -31i. Does that make sense? Okay, what else can we look at?
$20.
20, we have the polynomial inequality x to the third plus a 2 x squared minus a 4x minus 8 is greater than or equal to 0. So we got to solve this. And so we're going to solve this just like we would solve a polynomial equation. I'm going to begin with my possible rational zeros. So we know that the possible rational zeros are the factors of your constant divided by the factors of your leading coefficient. Since my leading coefficient is 1, all I got to do is look at the factors of -8, plus or minus, plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. And then I got to go through and start finding actual zeros of the function. So I'm going to begin with x equal to 1. We're going to use synthetic division here. So we have 1, 2, -4, -8. Let's see what happens. Bring down the 1, multiply, add, multiply. I don't think this is going to do it. No, not going to do it. We get -9, which is not 0. So 1 is not 0. What about the -1? X equals -1. 1, 2, negative 4, negative 8. Here we go. Bring down the 1, multiply, negative 1. 1, negative 1. Negative 5. I don't think this is going to do it either. Not equal to 0. Alright, so next possibility. What's the next possibility? 2. X is equal to 2. 1, 2, negative 4, negative 8. Bring down the 1. 1 times 2 is 2. Add, you get 4. Times 2. Oh, times 2 is 8. There we go. I was worried for a second. Which is a positive 4 again. Times 2 is going to be a positive 8. There's our 0. So x is equal to 2. There's a 0 of the function. Now, from this, I'm going to rewrite this as x squared plus a 4x plus 4. And we want to solve this. What are the factors of 4 that add up to 4? How about a positive 2 and a positive 2? This is kind of interesting. Which then means that x is equal to negative 2. Okay. So on our number line, I'm going to plot the negative 2 and the positive 2. Or equal to 0. So I'm going to go ahead and make those solid circles. Now, what I got to do is I got to go through and figure out whether or not the function is positive or negative between these values. So here's my work that I'm going to do. I'm going to do f at negative 10, f at 0, and f at positive 10. Now, I'm going to be able to do this mentally. If I do negative 10, now negative 10 cubed is 10 cubed is 1,000. So if I do negative 10 cubed, that's going to be a negative 1,000. Now, negative 10 squared is 100, times 2 is 200. Well, if you combine that with the negative 1,000, it's still negative. And even adding these together, that's still going to be negative. This is going to be negative. At 0, this doesn't take a whole lot of work either, because at 0, all I have to do is plug in 0. All of my x's become 0. I'm left with negative 8. That's also negative. Then if I plug in positive 10, alright, positive 10 squared, so you got 1,000, and then that's going to be 200, so you got 1,200. This is small beans compared to that.
Your conference is scheduled to end in 2 minutes.
Positive. So we have negative, negative, positive. So when is this function greater than 0? When is it positive? It's positive from 2 on. So in interval notation, this becomes positive 2 to infinity. And that's how we solve polynomial inequalities. Does that make sense? Okay. All right, our 2-minute mark just passed. I don't have any time for any more questions. This is the last time I'll see y'all this semester through the ITB system. We won't have class on Monday. Now, if you are in this classroom and the ITB system connects, I'm going to be in here because I have some final exams happening in this classroom. I'm not gonna be probably talking to y'all through the ITV system, but if you have a homework question, shoot me an email and I'll get your question answered, or a review question. Shoot me questions over the course of the weekend. Now, over the course of the weekend, I may or may not get to them immediately. I may not get to them till Monday. But feel free to shoot me some emails, and I will do my best to get to them in a timely manner. Starting on Monday, I'll be entering my emails on a daily basis. Alright, so, again, it's been an enjoyable
Your
semester.
conference is now over. Goodbye.
Good luck on your final exam, and I'll see y'all later. Bye.